Good morning, and should I say good afternoon and good evening to our international guests. Welcome to our AnyLogic webinar today, and we're going to be talking about the application of simulation in the warehousing and transportation environment. My name is Derek Majulton, and I'm the Director of Business Development here at AnyLogic North America, and I'm based in downtown Chicago, Illinois. Now, before we start, just a little bit of housekeeping. We have muted all of your phones and connections to the webinar. This is just to minimise background noise. And also, I'd like to let you know that we will be having a Q&A session at the end of the webinar. So if you'd like to ask a question, you can type those questions in via the little questions tab on the GoToMeeting window. Now, whilst many of you are fully aware of AnyLogic and its powerful industry-leading simulation capabilities, I know that there are some of you that are less familiar with AnyLogic and simulation. So for today's webinar, we're going to focus on the business applications of simulation, specifically in the warehousing and transportation sectors. So that's internally within a warehouse and the transportation in and around a warehouse and surrounding road networks. So the agenda will be this: a brief description of the AnyLogic company, followed by a slide or two about why you should use simulation to help solve business problems. Then we will dive into some case studies. The first one is a warehouse operation. We're going to discuss the internal operations. And the second case study is traffic and traffic flow in and around some warehouse facilities. And then we'll close things out with why you should choose AnyLogic as your simulation platform and a question and answer session. So the AnyLogic company has been developing simulation software for almost 20 years. As you can see by the audience today, we're very much global. We play in all major markets, and we're used by more than 40% of the Fortune 100 companies. So in addition to our diverse customer base, we would say we're the leader in the dynamic simulation market. And if we look at two data points, I think this clearly shows why we're the #1 simulation platform. If we look at an analysis of last year's winter sim presentations, what vendors were referenced, we were clearly #1. And also if we look at the LinkedIn user groups, the technical forums, which is an indication of the active users that each company and each product has. What we can also concur from this is there's been a strong move away from pure discrete event simulation to more sophisticated modelling that uses agency as well as that process-centric functionality. So why should we use simulation? Quite a simple answer to this. So our customers are faced with real problems day to day, business problems they're trying to solve in the real world. And in this case, let's talk about a supply chain problem. Now, to make a change or improve that problem, solve that problem in the real world, it might be very expensive, it might be time consuming, it might be dangerous. So if you go and build a warehouse in the wrong location, there could be significant consequences and risk to your business. So we advocate that you move into the virtual world, the risk-free world of simulation, where you can replicate the real-world environment and then undertake whatever type of analysis you need to solve your business problem. It might be an optimization, it might be a Monte Carlo or a sensitivity analysis experiment, or it might simply be a what if. What if we added a new distribution centre on the East Coast? How would that change our supply chain? Now, once you've come up with a solution and validated that solution through simulation, you can then come back down into the physical world, the real world, and institute those changes. Think of it as a digital twin, a little bit of a buzzword that companies like Gartner are throwing around, but in the simulation world, we've been using this digital twin for decades. So let's look at functionality, and this is one of the reasons why AnyLogic's become the #1 simulation platform. And I just want to touch on a couple of key functions that we've brought to the market over the past few years. So in 2014, we introduced GIS capability, real integrated GIS functionality, so you can visualize where your customers are, where your distribution centers are, where your manufacturing centers are. So anything you want to represent in a geospatial way, you can use GIS to provide that visualization. And then if we jump forward to 2016, we introduced a road traffic library. And we'll touch on this later on with one of the case studies. But the ability to very easily replicate vehicle behaviour, simulate the actual behaviour, and not just on public roads, but we have customers using it to simulate vehicle flow in and around distribution centres, cross docks, and also places like airports and hospitals and intermodal terminals. Very, very powerful tool to help solve problems. And then if we move forward to earlier this year, with the introduction of AnyLogic version 8, we provided a cloud platform, the Amazon Web Services. So not only can you build these powerful models, but you can export them up onto the cloud and utilize the resources and the power of the cloud computing environment. In addition to that, it makes it very easy for you to distribute the models or the outputs of the models to whatever audience you like. It could be your customers or it could be internal users within your organization. And then if we look forward, the next version of AnyLogic, which we'll be introducing at WinterSim next week, includes a material handling library. This will have very sophisticated conveyor networks, robotics, AGVs and automation, drag and drop functionality to enable you to replicate the most complex warehouses, distribution centres and manufacturing centres. So look, let's go and have a look at one of these models so you can see what they might look like. And I'm going to show you the AnyLogic cloud. So what I have here is our cloud, so it's just in a Chrome browser, and this is the output. This is the data output of a model. And you can see it's very clean graphics. But let's run one of these models and see what they look like. So the model I'm loading up is a product delivery model. And what it shows, this shows products being manufactured and then distributed to customers. And it incorporates GIS that you can see, but it also takes advantage of agent-based modelling, discrete event simulation and system dynamics. So we can see the production is a system dynamics, the delivery is a discrete event simulation, but all of the entities in this model are agents. Now the other thing that the models will show you is powerful analytics and statistics. So what we have here in this model is inventory levels, waiting times and utilizations. And all of these analytical outputs are customizable to whatever model you're looking to develop. So business applications for simulation, and the focus here is warehousing and transportation. So if we look at warehouse operations, you know, we're seeing radical changes in the use of automation and new technology into that environment. So one example might be the Kiva robotic systems that Amazon use. So instead of traditional racks and shelving and pickers going to the racks, the Kiva system brings those racks to the picker. Big change in how you might want to lay out the internal operations of a warehouse. And many of our customers use our software to help with resource optimization. So what are the optimal number of staffing units, of forklifts or loading docks do they need to deal with a projected throughput through a facility? If we dive into the inventory level within a warehouse environment, so our customers have changing inventory needs, maybe there's changing replenishment policies, maybe there's changing in safety stocks, there's new product integrations. So all of these are going to change the internal operations. So our users create models and then tweak and fine-tune the processes to make their operations more efficient. In addition, capacity and throughput. So two terms that often get mixed up, but they're very different in nature. So throughput represents the amount of material that flows through a facility over a period of time. But capacity is what space you need to process that material flowing through. So it very much depends on the dynamic nature of that material flow as to what your capacity might be. So two different points, simulation, very, very great to help you determine what capacity requirements might be. And then finally, capital expenditure. Very common for someone to be saying, do I need to build a new warehouse, or maybe we can readjust the internal layout, the format of their existing footprint to be more efficient, to deal with more throughput or deal with new customers. So how to avoid or minimize the need for additional capital expenditure. Now for transportation, there's always mergers and acquisitions in that sector. And then we have new entrants. So recently we had the Amazon purchase of Whole Foods, shockwaves through the grocery and supermarket industry, but now we've got a big new player changing the rules. So a lot of things might need to be adjusted and tweaked in that sector. We also have new technology. So 2 weeks ago, Tesla announced the electric truck. So a very different way of expending transportation costs than traditional diesel ones. It's also a forerunner to autonomous truck driving. So clearly there's going to be a big shake-up in how vehicles and the types of vehicles and the cost structures of those vehicles over the next 5 to 10 years. Of course, we have changing markets. Some areas we get increases, other areas there's decreases, so nothing new there. And then from transportation, congestion is clearly a significant problem. Not meeting your customer delivery times due to traffic congestion is a problem. And we'll be touching on that in a case study in a few minutes. So the first case study is a medical supply and pharmaceutical distributor. And let me just show you what one of these models might look like for you. So this is a distribution center model, and as you can see, when you start the model, you have the ability to change certain parameters. So in this case, the number of pallets, the number of loading docks, things like that. Now we can run the model and we can see a two-dimensional perspective of the model. We can see things, vehicles moving in, being unloaded. We can see material moving around this distribution center. We also have the ability to have a three-dimensional view. So you can really see individual operations, gives you that good feel, great for portraying a story to executives. The other powerful attribute of these models is the ability to collect analytical statistics, but also to change parameters over time. So we could change the number of docks, the number of forklifts, the size of the loads, whatever those variables might be, and then look at what the impact that might make. So in this case, we're looking at processing time in each region of this distribution centre or utilisation of the different areas within that facility. So the first case study is Cardinal Health. Now you might not have heard of Cardinal Health, but they generate over $100 billion in revenue, and their primary focus is the delivery and supply of medical devices and pharmaceuticals. So they have a number of unique challenges to meet. The nature of their business is they deal with very small, physical small products. Think of a box of medicines, so they're not big pallets or anything like that. Small volume. They can be very expensive. They have a very short shelf life. Often pharmaceuticals have short shelf lives. And then they have a very high volume of orders. So they're delivering to over 100,000 customers per day, sometimes multiple deliveries per day. So they have just-in-time delivery, and it's very critical that they meet those service levels. So very unique challenges. They also had experienced at some of their distribution centres an increase in overtime. So that was one of the primary challenges. How do they bring their average shift time from 10 or 11 hours back down to sort of 8 hours? So to do that, they also have to consider the processes within their operations, and these are often regulated. Because there's pharmaceuticals, they've got to have certain regulations. They have to restrict access to from certain people to certain products. So there's many variables and moving parts in that. And in addition, they have the option of vastly different internal layouts within their facilities. So different racking structures, shelving structures and things like that. So there's quite a lot of moving parts. And also just on that, the picking process is fairly manual with people pushing small carts around. So don't think about big forklifts and big wide aisles. It's quite tight. So what did they do? They used AnyLogic and followed a couple of processes. For a start, they had an operational research team undertake an investigation to look at various picking processes that they might be able to introduce. In addition to that, they looked at what were some of the staffing level challenges that they had, what sort of different processes, different order handling, so many parts that these OR team worked on over a period of time. From a data perspective, they were very lucky in that they had very good, clean data. So real-time data for when orders came in, when they were picked, if there was some sort of product shortage, when they were shipped, etc. So in addition to the process modelling, so the picking process, they had to consider the need for the behavioural attribute. So congestion and the behaviour of these staff that are picking these orders. So that dynamic activity, that unexpected activity is critical for them to understand the flow of material through this operation. So it's not just a process that they were looking at, it was the process and the interaction with the staff and that sort of human or behavioural element. So they had to, or they decided to use agent-based modelling as that is the best way to naturally represent that staff behaviour. And that includes, you know, different learning abilities, different restrictions, certain people are restricted to certain areas, things like that. So all of that was included in their modelling operations. And what was the result? So they went through a number of iterations in understanding what would be an ideal process to improve the total performance of their distribution centres. And every time they used AnyLogic to validate and to prove out whether one process was better or worse than the other. Now, the outcome of that was that they managed to reduce the average shift time from more than 10 hours down to a little over 7 hours. And this represents a saving of over $3 million per year at this one facility. So bottom line profit of an additional $3 million just by improving processes and reducing overtime. So a massive return on their investment for that project. Now the next model I wanted to show is this next case study concerns a 3PL and warehousing and transportation. And let me just show you what one of these models might look like. So this is AnyLogic, and I'm just going to compile the model. It's loading up, compiling it right now. Hopefully you can see this, this model. So you can see that the model includes GIS, and we have the road traffic library, so we have these main roads, and we have a warehouse or a distribution centre here. Now what we can show with the AnyLogic road traffic library is congestion points and traffic density. So very important to understand where are those congestion points in this sort of analysis. We also, in this model, we've represented the internal operations of the warehouse. So we can connect the behaviour inside the four walls to the flow of vehicles and the activity outside of the four walls. And we can get a three-dimensional view. Zoom in, zoom out. So let's talk a little bit about what that meant to this customer. So the customer we have here is a 3PL. They have about 20 to 25 warehouses in North America, a total of over 10 million square feet of storage. So the challenges that they were facing was, one, how to best utilise the flow of vehicles in and around their facilities. So some of their facilities, more than 250 trucks coming in, and they were getting bottlenecks and delays getting trucks in and out. What that was leading to was some dissatisfaction from their customers because their customers could not meet their service delivery needs. So congestion and delays getting trucks in and out of these warehouses was impacting the performance of their operations, their business. So the concept here was, well look, let's use AnyLogic and the road traffic library to simulate vehicle flow and to see if we can minimise congestion and bottlenecks. So the results that they achieved was improved loading and unloading processes and where they stored the trucks and the trailers, and also their drayage process. So the flow of vehicles, they managed to improve that and better utilise the resources that they had. They also took advantage of the heat maps that were showing congestion, so those choke points, and that led to streamlining security and gate procedures, because that was where a lot of the bottlenecks were. It also provided them an opportunity and a platform to investigate new technologies. And one of these technologies is the Amazon Relay application. So the ability for truck drivers to bypass the security and get in and out of a facility faster. A little bit like the TSA check-in, fast tracking. And then from a business perspective, this 3PL could use the models to help their salespeople quickly determine whether a facility had the capacity to handle new business. So when they were bidding for new business, they could quickly say, yes, we've got capacity to meet your requirements and your service levels, and so they could get those bids and those projects in faster. So now, why AnyLogic? So I just want to summarise a little bit. So AnyLogic supports not just discrete event simulation, but also agent-based modelling and system dynamics. And as I mentioned before, we see a huge move away from pure discrete event simulation. It's not enabling our customers to solve their business problems appropriately, so they're moving to AnyLogic because they want to include that behavioural and environmental agency into their modelling. AnyLogic, it's Java-based. So what does that really mean? It means it's fully interoperable to the rest of your analytical technologies. So you can integrate the models with any sort of data source, any type of optimization tool, any of your analytical tools, whether it's R or SAS or something like that. In addition, more customers now are integrating artificial intelligence or machine learning algorithms with the AnyLogic models. It's scalable. So the power of agent-based modeling means you can literally run millions of agents in parallel. Plus, we provide you with the Amazon Web Services cloud platform, so you can really take advantage of that. So it's the most scalable solution on the market. We touched on some of the functional libraries that we've provided. So these enable your modelers to build, to utilize out-of-the-box drag and drop functionality, making model building faster and easier. So we touched on the road traffic library, the process modeling library, the material handling library, but for those in the rail industry, there's a rail library, a fluid library for oil and gas, a pedestrian library, etc. So simulation, it can really help you. That old adage, fail fast, fail often. Well, with the risk-free world, you can certainly fail fast at virtually no cost. So it's a very risk-free application. And finally, AnyLogic, as you've seen from the above, is the most powerful, the most flexible, the most functionally rich, and the lowest risk simulation solution on the market. So I just want a quick promotion before we finish and get to the Q&A session. We have our annual users conference coming up in Baltimore in April, immediately following the Informs Business Analytics Conference. Now, if you'd like more information about today's webinar and our products, you can contact me, derek@anylogic.com, particularly if you want to take advantage of our 2017 pricing. We're getting close to the end of the year. We will be at the WinterSim conference next week, so those of you attending that conference, please come and see us. We're a principal sponsor there. Now let's open it up with some questions and provide some answers. And for this, I'm going to bring in one of our modelling superstars, Arash Mahdavi. Good morning, Arash.
Good morning, thank you.
Okay, first one. Do you have an example of a financial decision-making model for ROI calculations versus business process simulations?
So any of our models, any model that is process-centric or agent-based models, any operation could be associated with cost and profit. So you can calculate return on investment on any of those models by just adding those attributes to your model.
Right. Yeah, incredibly flexible in that regard. What we have here, can we expect a cloud-based simulation design platform anytime in the near future?
So the current roadmap is we are still going to have AnyLogic as a desktop application for your development environment, but for deployment of your models, you can use our cloud platform to upload it and share it with others on the cloud.
Right. Good. Okay, these are pretty straightforward. How do I insert probabilities and distributions for model parameters?
So AnyLogic supports, like, it has a wizard for more than 40 different types of conventional probability distribution. So you can use that. It's a couple of clicks to use that, and you can use even empirical data for empirical distributions as well.
Right, and for those of you that want more technical overviews, the AnyLogic YouTube channel has many short videos that show you, certain technical functions of our product. So this webinar we wanted to keep fairly business related. The next one, is there any reference model regarding products with very limited shelf life?
So again, similar to other questions, so AnyLogic supports this agent-based attributes for each individual product and all the actors in the model. So you can easily associate some sort of way of capturing how something is going to decay process and incorporate that into your model.
Would state charts work well in that environment?
Yes, state chart will be.
Okay. Yeah, for those of you that are not familiar with agent-based modeling, go and have a look at state charts. It's incredibly powerful. Okay, the next one. How can I insert custom logic, e.g. special constraints for sales order picking?
So it will be a similar type of thing. So you can use state charts, you can use action charts, and write your own custom logic to pick and choose from all the orders.
Right. So with agent-based modeling, every order can be a unique agent. So certain attributes and priorities can be defined as that order flows through the system. So it's not just, another unit moving. They're all unique and can be monitored and analyzed individually.
Yes.
Okay. How can simulation be integrated with big data and IoT initiatives?
So back to the previous question. So those attributes and individual level information for all these things that you have in the model could be read from databases. So AnyLogic automatically could be connected with relational databases, any type of relational database, and read those data. So it incorporates the big data pretty easy. And because it's a Java program, so you can have, if you have any API with other physical tools, and you want to connect with sensors, those type of things, it can easily be used, be connected through those APIs.
Correct. Yeah, it's very interoperable. Does the tool provide an interface or built-in functionality for stochastic optimization?
Yes, AnyLogic AnyLogic Professional comes packaged with OptQuest optimization engine that does stochastic optimization, and it has an interface to build those optimization experiments pretty easily. So you don't need to do anything hard. So it's just pretty easy.
Okay. So look, I'm getting the wind up that we need to finish the webinar. If you've got other questions, please feel free to contact me, Derek at AnyLogic.com. I'd just like to thank you for joining us this morning on our webinar, and I hope you have a very enjoyable day. Thank you.